Today, we're going to be determining whether two triangles are similar. So, similar shapes have to be the same shape, but not necessarily the same size. So, it's not like you can compare a rectangle to a circle or, a trapezoid to a triangle. So, you have to compare the same shapes, but they don't have to be the same size. Corresponding angles and corresponding sides of two or more similar shapes are in the same relative position. So we'll talk more about that when we get down to the rules right here. But first, what we gotta do is the symbol. So this symbol, this squiggly symbol, is similar. So the little squiggly means similar. In the figure shown, the sides and angles that are the same color correspond to each side. So they say triangle ABC is similar to triangle DEF. All right, so I'd use a little trick, and it helps in the past. So they say triangle ABC, so you're going to write ABC is similar to DEF. So then you're going to draw your ratio line similar to DEF. So now you know A corresponds to D, B corresponds to E, and C corresponds to F. When you write it like this, you can actually figure out who corresponds to who. Okay, and I'll show you more of that in a second. So it says in two similar figures, the measures of the corresponding angles are equal. So it means that angle A and angle D have to be the same. Angle B and angle E have to be the same. Angle C and angle F have to be the same. So the lengths of the corresponding sides are proportional. So that means that they don't have to be the same. But what happens is like angle B and angle D have to be proportional. So that means that if this was angle 2, this can be 2, 4, 8, so on and so forth, as long as it's increased by the same. So this can be 1, and so if 2 was increased to 4, that means this one has to be increased to 2 because we're increasing it by 2, multiplying by 2. And we'll get more into that in a second. All right, let's look at our first example. So your first example says, explain whether the triangles are similar. So the first thing I always do is check the angles. So the angles have to be, man, that's a weird E. The angles have to be equal, okay? Well, this is triangle. We have triangle DEF to triangle QRS. So that means angle D has to be, so angle D has to equal angle Q. So angle D is 40. So this is 40. And angle Q is 40. So 40 equals 40. So that's good so far. So now angle E has to equal angle R. Let me move this out of the way. Angle R. Angle E equals 106. So does angle R does? Yes. So it means they're equal. Finally, angle F has to equal angle S. Angle F is 34, and angle S is 34 as well. So my first check the angles. They are proportional. Okay? So my next one, my second thing I gotta do, see if, man, it's a weird F. If the sides are proportional. So the way we do it, so again, we have triangle DEF to triangle QRS. So I'm going to look at my first side I'm looking at is DE. So this one. So I'm looking at side DE. Well, so DE goes to QR. So DE equals 7 over 21. or 1/3. I simplified it. And I'll show you why we simplify it here in 1 second. So the next link I'm going to look at is EF. So EF goes with RS. So EF is 8. RS is 24. Okay, so now I'm going to simplify this again. That's 1/3. So the reason why we simplify it is because it's easier to compare. Because if all of these sides equal the same ratio, then they're means proportional. So for right now, both my sides equal 1/3. So now I got to check the last one. My last one is FD. FD goes with SQ. FD is 12. SQ is 36. Okay, if I simplify that, that's 1/3. So all these are at 1/3. Since they all equal the same thing, that means it's proportional. Okay, let's try another one. So this would be one on that you do by yourself. So you might want to pause the video to see if they're proportional or not, if you can do it by yourself. Okay, the first thing you should always do is check the angles. The personal reason why I check the angles first is because it's a simpler check. Okay, all you have to do is look at the same to see if the numbers are the same. So I have triangle A, B, C to triangle D, E, F. So I'm going to look at angle A to angle D. So angle A is 54 and angle D, whoops, we don't have to write that. Angle D is 49. These do not equal. Automatically right here, this means not similar. So the answer is no. These are not proportional, nor are they similar. All right, let's try another one. So are these figures proportional? Okay, so we got to figure it out. Well, our triangles have been rotated. So again, that's the reason why you say triangle ABC similar to DEF. That way you can line up your numbers, your letters to the corresponding sides. So first thing I'm going to look at is the angles again. So I got angle A is equal to angle D. It looks like a K. Angle. Angle A is 33. Angle D is 33. Okay, so we're good so far. So now we're going to do angle B to angle E. Angle B is 129. Angle E is 129. Okay, we're good. Last check for the angles. Angle C is equal to angle F. Angle C is 18. Angle F is 18. Okay, so good so far. Okay, it is proportional. It is similar so far. So now what we're going to do is we got to check to see if our sides are proportional. So the first side I'm looking at is AB. Okay, to AB goes to DE. So AB is 4. DE is 16. Well, that simplifies down to 1/4. Okay, my next one is, let's do BC. Not BC goes to EF. BC is 7. EF is 28. Oh, good. That's 1/4 as well. All right, last one. Last one is CA. CA goes with FD. CA is 10. FD is 40. Well, I can just cancel out those zeros and equals 1/4. So the answer is yes, they are proportional. Yes, they are similar. All right, let's look at another problem. Example 2. Diana makes 2 size of earrings. Explain whether the shape of the earrings are similar. Okay, so we got to determine if they're similar. So the first thing I'd check is if they all have the same, if they have equal angles. So first off, I'm going to do is I'm going to say, we're going to do MNOP is equal to Q, not equal to, but similar to QRST. So it means that angle M goes with angle N. Angle M is 125. Whoops, I had a brain fart. My bad. Let me restart. Angle M is equal to angle Q. Okay, they're on top of each other. Angle M is 125 and Q is 125. Okay, good so far. Angle N goes with angle R. Angle N is 86. Angle R is 86 as well. Okay, angle O goes with angle S. Angle O is 101. Angle S is 101. Okay, last one. Angle P is equal to angle T. Angle P is 48, and angle T is 48. Okay, so good so far. So that means all my angles equal each other, or to the corresponding angles equal each other. So the first step is done. Now we got to determine if their sides are proportional. So the first side I'm going to look at is side MN. MN goes with QR. MN is 10. QR is 6. So that can be simplified down to 5/3. So side NO goes with RS. NO is 10, RS is 6. Okay, well, we're equal, no, that equals 5/3. So that equals each other. OP is equal to ST. OP is 18. ST is 10.8. Oh, wow, we have a decimal this time. Interesting. We'll come back to that one in a second. So let's do, finally, PM. PM goes with TQ. PM is 15. TQ is 9, which then that does simplify down to 5/3 as well. So all we got to do is determine if this is 5/3. So another way we can do it is divide. We can divide, and when you divide these, you get 1.6, 1.6, 1.6, and 1.6. So yes, all of these do equal each other. But let me show you one way that you can prove that they're proportional. So we know 10/6 equals 10/6. All right, so that's a proportional. Well, if all of these side lengths are proportional, that means if I do 10/6, if I take this ratio and compare it to this ratio, that means that they have to equal each other because they all equal the same thing. So 10/6 has to equal 18 over 10.8 as well. One way to check that is actually by cross multiplying. So you can do 10 times 10.8. 10 times 10.8 is just 108. Then you can do 18 times 6. 18 times 6 is 108. So if these two numbers equal to each other, then it's proportional as well. All right, let's try that again. So we know that 18 over 10.8 is proportional. Let's prove 10/6 is equal to 15 over 9. Way we're going to do that is through cross multiplication. So you're going to do 10 times 9, which is 90. 15 times 6, which is 90 as well. They equal the same thing. If those two numbers come out equal to each other, that's another way to do it. So you can do it like this, or you can set up a proportion to determine if they're equal. Okay, and we'll practice more with these. So are these figures proportional? So I have a rectangle, A, B, C, D, that has the sides of 7, 5. Then I have another rectangle that's bigger, which is labeled M, N, O, P. And for them to be rectangles, they have to have the same degrees. They have to have a 90-degree corner. So the sides are 21 and 15. So we're going to determine if they're proportional. So you can do 7 over 5, and 7 over 5 equals 7 over 5. And you can do, so you can do 7 over 21, which is 1/3. And then you can do 5 over 15. I made these a pair, and then I made these a ratio. So 5/15 is 1/3. So they both equal the same thing. So yes, they are proportional. So remember, I can do this a different way. Instead of actually writing down the ratios and simplifying it, you can actually cross multiply. So we're going to take the same ratio, 7/21 is equal to 5/15. So we're going to cross multiply. So you're going to do 7 times 15, which comes out to, let's do some quick math, 105. And 21 times 5 is 105 as well. So they're equal to each other. So we just proved them 2 different ways, by setting up the ratio and simplifying, and also by setting up a proportion and cross multiplying to see if they get the same number. So they do. Yes, they are proportional. All right. Last one, number 5. So first thing I'm going to do is I'm going to check if the angles are the same. So these angles are the same. All these angles equal each other. So I am not worried about that. So now let's see if the sides are proportional. So I'm going to look at the 8. The 8 goes to the 48. So the 8 goes to 48. And then we can have 6 goes to 6. So let's cross multiply. Well, 8 times 6 is 48. And 6 times 48 is going to be much bigger than 48. Let's just do it. It should be, comes out to 288. So do these equal each other? No. I could also have just looked at the figure. I can see that 8 went increased to 48 and 3 increased to 15, while these sides, the 6s stay the same. That can't happen. So they all have to be increased by the same number. Okay, that's it for your notes. Your main idea is practicing setting up proportions. The reason why we're practicing setting up proportions, because not tomorrow, but the next day, Wednesday, is you're going to learn how to set proportions up and then find the missing sides. So if you do get stuck on this, please let us know. We are doing an activity tomorrow to help us concrete this idea. But other than that, please watch my video. Have a great day.